Hi, my name is Scott Page, and I'm a professor at the Ross School of Business at the University of Michigan. What I want to talk to you today about is how is it, when is it, that diverse groups outperform homogeneous groups? And the logic that I'm going to present is something that I call diversity bonuses. It explains why is it that diverse groups gives you that extra 5%, 10% over homogeneous groups. And the idea is going to be this, is that diversity ends up being really beneficial when the task before you, the problem at hand, is really complex. If it's easy, you don't need a team and you don't need a diverse team. It's when the problems are hard. So what do I mean by complex? By complex, I mean something that's difficult to explain, or engineer, or evolve, or predict. Right? So think of the global economy, that's complex. If you think of middle school, that's complex. If you think of the brain, that's complex. If I think about something like, cutting a 2x4 to a specific length, that's not complex, and I can just have one competent person do that job. So if I look at trying to predict or forecast within the economy, some things are going to be complex, like oil prices, and other things like oil production are going to be less complex. And so where we need to put teams together, where we get these bonuses in diversity, are on the more complex tasks. Now to walk you through the logic, it's not going to be some sort of like one size fits all, and now we sprinkle on some diversity and we do a lot better. We actually have to have a mechanistic understanding of what is the nature of the task, what is the type of diversity, and how does the type of diversity make us better at that task? So let's start with prediction or forecasting. So now what we've got to do is we've got to figure out, should we hire this person? What's going to happen in this market? What's possibly going to happen in this region of the world? And what we want to do is we want to see what are the advantages of putting a diverse group of people together in a room over just having a whole bunch of like homogeneous people or maybe just one really smart person. So let me start with some data. Google, which gets about 4 million job applicants a year, has to figure out a way to sort of sort through those. So what they do at first pass is use a computer algorithm. So what you see in this graph at the 50% line is sort of, if you just took someone from the algorithm, half would be above average, half would be below average. If they just have one person interview, they get a bonus up to 76%. So they're 26% better than the algorithm. Now the point isn't that the person is smarter than the algorithm. The point is that the person is different from the algorithm. Now they had a second interviewer, it goes from 76 to 81, a third from 81 to 84, a fourth from 84 to 86. So what you get is by adding interviewers, by adding this diversity, you end up having a 36% chance of hiring someone better than average. Whereas if you just had one person, you'd only be 26% better than average. Now the point here is when they're adding more interviewers, they're not adding on people that are smarter, they're just adding on people that are different. Each one of us, when we interview someone, we see that person through a different lens, and what you see is the crowd is more accurate than an individual. Now this phenomenon of groups being better than individuals is sometimes called the wisdom of crowds. That comes from a book by Jim Surowiecki where he talks about this West of England fat stock and poultry exhibition held in the 19th century, where 787 people guessed the weight of a steer. Average guess was 1,197 pounds. Actual weight of this steer was 1,198 pounds. So this is a great anecdote. They're within a pound, but we want to move from anecdote to science because we want to understand, when do we need the team, when don't we? So what does the science say? What the science says is we can write down a theorem, a formal mathematical identity that says the following. The crowd's error equals the average error of the people in it minus their diversity. What does that mean? So the crowd's error, that term you see on the left, C is the crowd's prediction, and that Greek term theta, that little circle with a line through it, that's the true value. So the crowd's error, you might think, is the average of the individual errors, like your stocks in a portfolio. But it turns out it's not. The crowd is more accurate than the average person, and the amount by which it's more accurate is the diversity of their predictions. Because if some predictions are high and some predictions are low, you end up with the crowd being more accurate than the average person in it. Now, this isn't just some sort of like feel-good idea. This is a mathematical fact. So if we look at the data from Galton Steer, the crowd, remember I said it was off by a pound. Well, we square the errors here because it's statistics. We do squared errors. They're actually off by 1.4 pounds. So when we square it, we get 2. The average error was over 70 pounds. So when we square that, we get something a little over 5,000. The reason the crowd was correct is that the crowd was also diverse. So what you get is the crowd error is really small because you had pretty smart people, but those people happen to be diverse. This is the key. And this is also why complexity is so important. Why do we need diversity on complex problems? So if the problem's complex, nobody's going to be right? The average error is going to be pretty big. We want the crowd's error to be small. So the only way we can make the crowd's error small if the average error is big is by making the crowd diverse. Now this happens and this plays out everywhere, right? It's a mathematical fact. So let me show you some data from economic forecasts. This is work by professors at Duke University. What they have is 28,000 forecasts by professional economists, 6 economic indicators. The crowd is 21% better than the average economist. Now, it's not 28,000 economists on each prediction. So typically it's like 40 or 50 economists making predictions. The crowd was 21% better than the average economist. Now, even more impressive than that, if you look at this red line, the red line starts at 1. That's the error for an average economist. If you just add in a second economist, you do 9% better. Even more amazing than that, take the purple line. The purple line is the very best economist. So the best economist in this data set is 10% better than an average economist. When you average her, and in a lot of the state it was a her, it was Abby Cohen from Goldman Sachs. When you average her with the second best economist, who by definition is not 10% better, you get 17% better. That's what I mean by a bonus. 10% plus 9% gives you 17%. The reason why is because they're diverse. So this is the key logic. When you think about why you have diversity for a portfolio, you do so because you want to minimize risk, right? So if one stock gets 8%, one gets 12, but one loses 8, right? On average, you get about 5%. But with predictors, and this is the data from The Economist, the best is 9% better, the next best 9% better, the next best 9% better, the next best 8% better. When you average them, 22% better. Bonus. So whatever logic you have, whatever reasoning you have for diverse stocks, which is risk mitigation, and however much diversity you have in your stock portfolio, you should have more diversity within your employees, because employees don't just mitigate risk. They do that also, but they give you a bonus. And that bonus, in this case, is enormous, right? It's, the value add from the bonus is larger than the value add from having the best predictor in the market. All right, that's prediction. Let's look at problem solving. The logic here is entirely different, but again, we're going to see a bonus. So let's think about how problem solving works. You've got some sort of difficult problem. You've got a bunch of problem solvers that set loose on it, like they represent it in some way. They think about how they're going to find better solutions. I find an improvement, and Lindy builds on my improvement. What you can show here, Lu Hong and I showed this in a mathematical paper in 2001, that if I take a whole bunch of really competent problem solvers, these are represented as kind of mathematical algorithms, I'm actually better off taking a random group of competent ones than taking a collection of the very best. And the reason why is the collection of the very best aren't diverse. So when one of them gets stuck at a point, since they're all representing the problem in similar ways, they all get stuck at that same point. When I have a diverse group of problem solvers, they get stuck at different points. Now this was a somewhat controversial paper, so there's a bunch of follow-ons, and everybody who's done a follow-on has found pretty much the exact same thing. And here's one by John Kleinberg and Maitha Raghu from Cornell. They said, okay, let's think of problem solvers as people who sort of like come in with a set of ideas, right? And then what happens when we're in the room, we combine those ideas in an interesting way. We build off those ideas. What they show is that if you do something interesting in the group, as long as it's not just kind of like adding up and taking an average, if you do something interesting with these solutions, then there's no test that you could apply to individuals such that the best team consists of the people who scored highest on that test. So in other words, if you're putting together a team, you can't put together that team thinking in terms of individual performance. You want to think of that team in terms of diversity. Now, these are theoretical results. What about empirically? Well, this was so sort of surprising to people that people then tested this in a lot of cases. And one of the most amazing tests is using IQ tests. So this is Raven's progressive IQ test. We can figure out which is the next pattern in the sequence. So this is a wonderful work where people wanted to see, would an IQ test work to put together a team to take an IQ test? And the answer is no. If you want to put together a team to take an IQ test, you actually don't want the people with the highest IQ. Now, why is that? Well, what you want is you want people who have high contextual IQ relative to the other people in the group. What is contextual IQ? Well, contextual IQ is this. Suppose that like I don't score that well on an IQ test, but I happen to get the questions right that the really smart people get wrong. So I get questions right that like other people are sort of confused on. Then you want me in the group. Now, yeah, I miss a lot of easy questions, but that doesn't matter because the rest of the groups get it right. So you want sort of people whose correct answers are correlated differently, right, who get different correct answers than most of the people. So if what you're trying to do is take an IQ test as a team, you actually don't want the people who score highest individually. You want people who think differently. All right, third type of task, creative tasks. Suppose we're trying to come up with just creative solutions, just generate ideas. What about diversity here? Well, let me give an example. This is something that's sometimes known as the brick test or the alternative uses test, where you have to think of how many ideas can I think of using a brick for. So I did a version of this with a corporate client where I said, okay, suppose you've got 10,000 plastic straws sitting in the basement. What can you do with them, right? How many ideas can you think of? This is known as the alternative uses test. The individual ability of a person is how many ideas they can think of on their own. The ability of the group is how many ideas the group can think of. So I did this with a corporate client. Here's the results. So one person, person A, the highest performing person, thought of 31 ideas. The lowest performing person, person J, thought of 5 ideas. You could say, okay, A is the most creative, B is the second most creative, and so on. But when I combine these people, I get 103 ideas. Because what I can do is I can sort of take the union of all their ideas. If there's a duplicate copy, I throw it out. And what you see is the group is far, far more creative than any one person in the room. And in this case, if we look at person B and person C, even though they had the same individual diversity, person C actually thought of a lot more unique ideas. So relative to the group, person C had more value than person B, even though on their own, they were equally valuable. So what we see in all these cases is the sum is better than the parts, and it happens in the form of bonuses. But let's think about this carefully. What is the form of diversity? In prediction, it's different categorizations of the world, different models. In problem solving, it's different representations of the problems, different tools, different analogies, different ways of kind of climbing the hill, thinking of little improvements. And on creative tasks, it's different sets of possibilities. It's just what can you think of? And then what is the logic? In prediction, the logic is by averaging these diverse models, you kind of eradicate biases, right? And some of the estimates that are too high and some that are too low, those kind of cancel out. In problem solving, it's this notion of iteratively improving. So I'm stuck somewhere, somebody else thinks of something new. Stuart Kaufman calls this the adjacent possible. I'm stuck, I can't think of anything better. Lindy can think of something new. Her adjacent possible is different than mine, making the group smarter. On a creative task, it's about the union of ideas, right? So it's my ideas plus Lindy's ideas plus somebody else's ideas, and the union of those sets is more than any one person knows. In each case, diversity bonus. In each case, a different logic. Okay, what about identity diversity? Because this is a course on diversity, equity, and inclusion. What about identity? Because I've been talking about different ways in people think. So you can think about identity diversity. Who we are affects how we think, and how we think leads to better outcomes. But we can unpack that a little bit more, because what do we mean by identity diversity? We mean things like gender, race, age, sexual orientation, ethnicity, social class, where we grew up, religion. Those things map into the information we have, the knowledge, the heuristics we develop, how we represent the world, the causal models in our head, our analogies, the books we read, the places we visit. What's inside our head is this kind of messy bundle of who we are. So if you want cognitive diversity, you have to have identity diversity. And the mechanisms through which that play out are actually fourfold. So first, as we just mentioned, identity diversity correlates with cognitive diversity. So if you want a diverse room in terms of how people think, you need diversity in how people look. Second, people think differently and harder when they're around identity diverse people. So this is work from Catherine Phillips. If I'm in a room with people just like myself, I kind of take it easy. When I'm in a room with people who are different from me, I just think harder. I generate new ideas. Third, identity diversity influences what people are experts in. So it's not just how we filter the world in terms of through our identities, but also what really interests people is strongly a function of who they are. And so our expertise is going to correlate with what we know. And then last, when you're drawing from a diverse pool, yes, it's larger, but it's also more diverse. So one reason you want to, even if there were no differences in people based on identity diversity, by hiring from an identity diverse pool, yes, you're getting more talent, but you're also getting more diverse talent. All right, sum it up. Diversity improves performance when the task is hard. When it's easy, someone can just handle it. It improves performance when the task is hard. And it's cognitive and identity diversity that really drive this, because who we are affects how we think. Last, when you think about what's going to give you sustainable competitive advantage, it's going to be your performance on these complex tasks. Thank you very much.